Good afternoon to all. The scientist discovered a new type of material or energy, but the engineer discovered a new use for it. On behalf of EEE Department, Office of International Relations and Collaboration Cell, in association with IEEE MGR Student Chapter, had organized international conference on electric vehicle and engineering in medical science. The topic of this section was development of intelligence driving cycle system to evaluate the energy consumption and environment for paying water taxi and basket driving cycle. Now I would like to invite Dr. R. Sivanandan Sir, Assistant Professor of EEE Department, to welcome speaker of this section.
Good afternoon, everyone. So, on behalf of our university and EEE department, I take this opportunity to introduce Dr. Salisa, assistant professor, sorry, associate professor, and she is a deputy dean in Faculty of Ocean Engineering Technology and Informatics of University Malaysia, Terengganu. She is also an advisor of the Energy Storage Research Group, University Malaysia, Terengganu, and also member of Renewable Energy and Power Research Interest Group, University Malaysia, Terengganu. She is an author and co-author of 43 publications with around 204 citations. Her research interests are in hybrid electric vehicles, innovation powertrain, stimulation and modeling, energy management strategy, driving cycle development and optimization. Dr. Salisa has H-indexed 7 in Scopus. So today, Dr. Salisa will be sharing his experience on a research topic, development of intelligent driving cycle system to evaluate the energy consumption and emission for paying water taxi and basket driving cycle. We welcome you, ma'am.
Can you see the slide?
Ma'am?
Yes. Okay. Hi everyone, and good afternoon. I'm Salisa binti Abdurrahman from Faculty of Ocean Engineering, Technology and Informatics, Universiti Malaysia Terengganu. Okay. Thank you for the organizer for inviting me as invited speaker for this conference. Okay, before I proceed with the research topic, let me introduce a bit about Universiti Malaysia Terengganu. Okay, Universiti Malaysia Terengganu is located in Peninsular Malaysia, specifically in the state of Terengganu. This is the map. Okay, our campus is near the beach and island such as Perhentian and Redang Island. Okay, Universiti Malaysia Terengganu has 5 faculties and 2 centers, which are Faculty of Ocean Engineering, Technology and Informatics, Faculty of Science and Marine Environment, Faculty of Maritime Studies, Faculty of Fisheries and Food Science, and Faculty of Business, Economics and Social Development. The 2 centers are Center of Foundation and Continuing Education and STEM Foundation Center. Okay, this is the Faculty of Ocean Engineering, Technology and Informatics. There are 9 undergraduate programs in these faculties, which are Maritime Technology, Environment, Electronic Instrumentation, Financial Mathematics, Applied Mathematics, Software Engineering, Computer Science, Maritime Informatics, Computer Science, Mobile Computing, and also Naval Architecture under Bachelor of Mechanical Engineering Technology. Okay, for postgraduate program, We have masters and PhD by research, and we also have 4 coursework programs, which are information technology, computer science, mathematics, and statistics in marine science. Okay, if you want to know more about our faculty or our university, please visit our website, specifically FTKKI, our Facebook, and our Instagram. Okay, today I would like to talk about research topic entitled Development of Intelligent Driving Cycle System to evaluate the energy consumption and emission for payang water taxi. This is a payang water taxi and bus kita driving cycle. Okay, in Kuala Terengganu, the public transport services were created to upgrade the public transport system in Terengganu State, including payang water taxi and bus kita services. The objective of this service are first to increase the level of mobility from one region to another, and second to provide a service system for travelers convenient, and third to provide cheaper, efficient and comfortable public services. This is due to the increase of fuel price, fuel consumption and emissions. Okay, the alternative to reduce the fuel consumption has been discussed. As we know, HEV or hybrid electric vehicle has become an effective solution to meet the tightening emission regulation and the need of more fuel efficient vehicle. It is because HEV has better energy economy and emission performance than the internal combustion engine vehicle. The driving cycle for new energy vehicles such as HEV can provide a reliable basis for the improvement of motor control strategy and vehicle machine that can be applied to evaluate the HEV engine economic performance and emissions performance. So in this research, a smart and intelligent real-time monitoring and control system of payang water taxi and bus kita driving cycle is implemented. This project also involves the IoT solution in order to receive, transmit and store the large and big data throughout the driving process. Okay, the objective of this research is first to construct an intelligent system for driving cycle management. Second, to construct and validate the payang water taxi and bus kita driving cycle for efficient operation based on our intelligent driving cycle system. And third, to analyze the energy consumption and emission of payang water taxi and bus kita driving cycle using autonomy software. Okay, the project methodology involves first construction of the intelligent driving cycle system, second construction and validation of payang water taxi and bus kita driving cycle, and third energy consumption and emission analysis of payang water taxi and bus kita driving cycle. Okay, this is the flow of project activities involved of the selection of the road and then characterize the driving cycle. After that, we develop the driving cycle. After we get the driving cycle, we do the validation and the analysis of energy consumption and emission using autonomy software. Okay, construction of intelligent driving cycle system. The main element in the proposed model are IoT gadget attached in the board or bus. Okay, in the proposed system, the combination of k-means and deep learning will use in order to maximize the accuracy, then to increase the capability of handling big data, and also to improve the efficiency and feasibility of big data technology. Okay, for the construction and validation of payang water taxi and bus kita driving cycle, in this phase, we do the validation of fire and water taxi and the driving cycle. The actual driving data collection was conducted over the selected road. Okay, this is the selected road. Figure 1 for bus scooter and figure 2 is for fire and water taxi. Okay. After we get the selected road, then we start to collect the data. Then we based on 9 common vehicle parameters. This table shows the 9 common parameters used for to develop the driving cycle. Okay. Then energy consumption and emission analysis for fire and water taxi. The data collected was extracted and analyzed using MATLAB simulated environment. After the simulation process is done, then the data of energy consumption and emission was collected, compared and analyzed using the autonomy software. This is the icon of the software. Okay, for result and discussion. Okay, for the validation, we do the validation on the MATLAB code has been made using a standard driving cycle such as EUDC, US06, LA92 and NYCC. As such, a total 9 parameters were tested to measure the accuracy of the MATLAB code with minimal variance as listed in the table. This is the for validation. Okay, then after that, after the validation, then we develop the driving cycle after we make sure that the code is already correct. The following observation are made from the developed driving cycle. As we can see, the speed range below 10 km was dominant here. This is due to the congested traffic condition in Kuala Terengganu city roads, and also due to role of public bus itself, which lead to have more stop and go condition. The micro trip at the higher speed range are longer compared to the micro trip at lower speed range, as we can see here. Okay, this is because the vehicle experiencing a free flow move at higher speed range with less frequent stop due to less traffic condition. A 21.49 km per hour average speed was recorded in the developed bicycle driving cycles. Okay, then this is the developed driving cycle of fire and water taxi. Okay, a 10.82 km per hour average speed was recorded in the developed fire and water taxi driving cycle, shows that the boat is moving at lower speed, since the boat is not a speed boat but a recreational boat. Therefore, lower fuel consumption and emission take place during that period due to the less stop along the river. After that, after the driving cycle has been developed, the energy consumption such as fuel consumption and fuel economy and emission can be determined using autonomy software. Autonomy is a tool for automotive control system design, simulation and analysis. Okay, from the table, it is clearly shows that the PHEV here is the best powertrain compared to the conventional bus. It is because the PHEV, of course, it start in all electric mode first, right? On electricity, when the batteries are low in charge, we call the internal ICE, internal combustion engine, to provide boost and charge up the battery pack. The ICE is used to extend the range. The HEV can charge the battery directly from the grid and have the facility to utilize the regenerative braking. So, as well as they consume less fuel, then reduce the emission. Okay, for fire water taxi, from the table it shows that the fire water taxi is the best, also the best powertrain compared to the conventional engine vehicle. The reduction percentage of fuel consumption is about 58%. Okay, as a conclusion, we can say that the development of fire water taxi and bus scooter is successfully done using microchip clustering by K-mean method. Fire water taxi and bus scooter driving cycle are successfully obtained and can be concluded that the proposed method is possible to generate fire water taxi and bus scooter driving cycle for hybrid electric vehicle powertrain to overcome exhaust emission and fuel consumption problem. For further study has to be made to other public services also in Kuala Terengganu City. So this is my research team, myself, and then this is Prof. Rezaidi. This is Dr. Faisal, Dr. Siti Nabaya. This is Encik Zul and Encik Karudin from Shasrikas. And this is our partner also from industry, Garisan Automotive. And this is our co-researcher, Associate Prof. IR, Dr. Shariman from UNIMAT. Okay, this is the LOI, and I end my presentation with thank you. So,
Thank you, ma'am.
mm-hmm.
Thank you, ma'am, for a valuable speech. Now, Q&A section. If participants have any question, you can comment in chat box. Ma'am,
Yes,
some of those participants having question, ma'am.
clarify about the hybrid
Yeah, I will read,
environment.
ma'am. Clarify
Yes,
about yes, ma'am. Clarify about does hybrid helps the environment?
yes, hybrid vehicle, yes, they have advantage on environment because for hybrid vehicle, the emission is less emit compared to the conventional vehicle.
Ma'am, one more question, ma'am. Can you please clarify about factors affecting the energy consumption of vehicles?
Uh, there are a few factors that affect the energy consumption. First, the driving cycle itself. Let's say if we drive on the vehicle in the city, then there's more stop and go condition. So it consumes more energy, more fuel energy, consumption. Second, I think the choosing of the component itself, the component of the powertrain. So that's why we have to before we design the vehicle, we have to select the right size and the right type of the component.
Ma'am, one more question, ma'am.
Yeah.
Explain
Um,
why are hybrid cars are better than electric cars.
okay. There's a difference, right? For hybrid cars, it hybrid between the electric and the fuel. For electric cars, it use only the electricity. Okay. For electric cars, it's like okay, if we have electric car, if we go the battery car lasts long, like say about 100 kilometer, then after that we have to charge. Uh, So, but for hybrid car, we have the engine and then the motor to charge back the battery, so we can go longer. But they have a emission. But for electric car, there's no emission.
What is the drive cycle on the cars?
Oh, actually, the life cycle is the input of the cars. The road, the trip we call it the drive cycle.
Ma'am, one more question, ma'am. What are the factors are considered in the typical drive cycle, ma'am?
Okay, actually, let's say for Japan, China, US, Europe, they have their own driving cycle. But for Malaysia, we don't have our own driving cycle yet. That's why I try to study the driving cycle for Malaysia.
Ma'am, one more, ma'am. What will be the durability of battery based on charging cycle?
What is the
What will be the
what is the
durability of
durability of
battery
battery
based on
based
charging
on the
cycle?
based on charging cycle? It depends on the type of the battery.
Thank you, ma'am, for clarifying all our doubts.
Oh, okay. Thank you. Bye.
Now, I would like to invite Monisha to deliver vote of thanks.
Good afternoon, all. I'm Monisha from third year of BMI. Here, I would like to thank our EEE department and Office of International Relations and Collaboration Cell for organizing this wonderful session. I would like to thank Dr. Salisa Abdul Rahman, ma'am, speaker of this section. Thank you very much, ma'am, for sharing a wide knowledge on our energy consumption system. I also like to thank the organizing team, committee, department faculty members, and students. Lastly, I would like to thank all the participants for giving us their precious time. Thank you all once again.